So this is physics, and we're going to finish up with section 12.2. Actually, finish up two more sections dealing with section 12.2. And what we're going to be looking at today is a famous experiment called the Millikian Oil Drop Experiment. It is how we found the charge on the electron. And it's a fascinating experiment. I will post a link to a YouTube video where you'll be able to see that. Can't read that real well, but let's bring that up a little bit better. Sorry about that. The room that I'm in is a little darker than my room at school. The Millikian Oil Drop Experiment was one of the most famous experiments ever done. You may remember that they found that there was a particle, J.J. Thomson, and he actually was able to find the mass to charge ratio, but he didn't know what the mass or the charge was. And it wasn't until Millikan figured out how to measure the charge on an electron. And the way he did it is, there's just so much good physics involved. He took two plates that had charges on them. This one would be negative and this would be positive. He took an atomized oil drops. So he had a spray where he was shooting oil in, and then he had oil droplets drop through this little tiny hole he had at the top, and he would measure how fast they were traveling, and by measuring how fast they were traveling, when they hit terminal velocity, he could figure out how heavy they were, and then he was able to get them by adjusting the voltage to get that oil drop to float in there. I forgot to mention he had an X-ray machine, and he was firing X-rays, and as a result he was putting charges on this. He was actually putting negative charges on. And then by adjusting the voltage, he could cause this to float inside of there. And what he did was he did a little bit of simple physics. He said, obviously there's a force down of gravity, there's a force up from the electricity, because this negative is repelling, this positive is attracting. He knew that therefore the force of electricity would be equal to the force of gravity. Now the force of gravity was mg, and this, if we go back, we find out that force is equal to the electric field intensity times Q, because E is equal to F over Q. And therefore, this was equal to EQ. And therefore, Q was equal to mg over E. And you may remember that V is equal to ED. Voltage is equal to electric field intensity times distance between the plates. And E then is V over D. And Q then was mg over V over D, and working that out, we get that Q is equal to mg times D over V. And he was able to come up with what the charge was on that drop. And what he found was that because when he's putting the X-rays on here, he's putting different numbers of charge. But he found out that these were all multiples. So he might have one that has a different charge than another one, but Q was always a multiple. Of 1.6 times 10 to the negative 19 coulombs. And as a result, that becomes the charge on one electron. And so this equation can be used to do that, or this could also be Q is equal to mg, as we did, over E. Over E, but E is equal to this. And so you actually have a few problems with that. We're going to do problems 26 through 29 in the book. And like I said, there's a little video that I want you to watch. And I think I have the answer for number 30. No, 26 through 29. The answer for 28, because you won't have that in the back, is 40,000 newtons per coulomb is the answer for that. One of the interesting things about this is the minute that we know what the charge on the electron is, we can also figure out what the mass of the electron is. And that is because there was a charge to mass ratio. In other words, they knew that Q times M was always equal to some number. And the number that it was equal to was 5.2 times 10 to the 11 coulombs per kilogram. And if you divide this 5.2 times 10 to the 11 coulombs per kilogram, and I've done something wrong here. I shouldn't do that. This is not the right number. But what happens is we know this was a constant, and because of that, now that we know what the charge on the electron is, we would know what the mass is. So, important experiment, and it ties in with some of the stuff that we've done. So with that, I'm going to stop with this video. Like I said, I will post a link to a little YouTube video that I want you to watch that takes you through and actually shows you how they calculate out, and Robert Millikian did his experiments. So, all right, we'll end this video at that point, and it does look like you can see the board, so that's good. And there will be another video that I'm going to put up on capacitance, and that will end this chapter. And then I think we're going to hold off on tests. We'll see where we are at the end of next week, and maybe we'll figure out something to do, but hopefully we'll be back after Easter break. So I'm going to end the video here. Hope to see you soon.